Everyone. In this video, I'll show you how to perform CRUD operations using Java JDBC, that means creating, reading, updating, and deleting records in a MySQL database with a simple console application. Let's get started. Let's start by creating a new Java project in VS Code. First, open VS Code settings. Now press Ctrl plus Shift plus P to open the command palette. In the search bar, type Java, create Java project and select it. For this project, choose No Build tool. Next, select the folder where you want to save the project. Then, give your project a name, for example, JDBC_CRUD operation. And that's it. Our Java project has been created successfully in VS Code. Let's execute a simple Hello World program. Inside the project, alright, our code is ready, now let's run the program. And there we go, we got Hello World in the output. That means our Java setup in VS Code is working perfectly. Before we start coding, we need to add the MySQL JDBC driver JAR file to our project. Download the MySQL connector from the official website, then place the JAR file inside a lib folder in your project. After that, right-click on the JAR file and select Add to Reference Libraries. This will allow our Java project to connect with the MySQL database. Now that our Java setup is working, let's move on to the main part of this video. We'll start coding the JDBC CRUD operations. Step by step, we'll connect our Java program to MySQL and implement options to insert, view, update, and delete records. Now, the first step in our code is to import the SQL package. Now let's define our database connection details. We'll add 3 variables inside the class, one for the URL, one for the username, and one for the password. The URL will contain the JDBC connection string along with our database name. The username is the MySQL user, and the password is the MySQL user's password. These values will help us connect Java with MySQL. To safely connect with the database, we'll wrap our connection code inside a try-catch block. The try block establishes the connection, and if anything goes wrong, the catch block will handle the error and print the details. Now we create the connection object. Here, con is our connection object, which links the Java program with the MySQL database. Next, we'll create a scanner object to take input from the user. The import statement brings the scanner class into our program, and with the SC object, we can read user inputs like course name, instructor, duration, and fee. Now, we'll create a while loop to continuously display our menu for course operations. Inside the loop, we print the options: 1 for select, 2 for insert, 3 for update, 4 for delete, and 5 for exit. We then ask the user to enter their choice and store it in a variable ch using the scanner object. This way, the menu keeps repeating until the user decides to exit. Now, we'll use a switch case to perform different operations based on the user's choice. If the user selects option 1, the code inside case 1 will run. Similarly, option 2 will run insert, option 3 will run update, option 4 will run delete, and option 5 will exit the program. This makes it easy to handle multiple operations in a clean and structured way. Before writing the full logic, let's first test our switch case. Inside each case, we'll simply print the operation name. For example, in case 1, we print select operation, in case 2, we print insert operation, in case 3, we print update operation, in case 4, we print delete operation, and in case 5, we print exit. When we run the program and choose an option, the corresponding message should appear. This will confirm that our switch case is working correctly before we move on to writing the actual database logic. Finally, we'll close our try block with a catch block to handle errors. This way, if anything goes wrong while running the program, it will show us a proper error message instead of crashing. Now let's run the program to check if everything is working properly. When we execute it, the menu should appear, and based on the number we enter, it should print the corresponding operation message. If that works, it means our connection, loop, and switch case are all set up correctly. Awesome! Everything is working properly, our connection, menu, and switch case are set up correctly. Now we're ready to start coding the actual CRUD operations. Let's start with case 1, select operation. Here, we first display the heading course list. Then we write a SQL query to fetch all the records from our courses table. We use a prepared statement and a result set to execute the query and loop through the results. Next, we define a Boolean variable found and set it to false. This will help us check later if any records exist in the table. Then, we print the table header using system.out.printf. Here, we format the columns as ID, course name, instructor, duration, and fee, each with proper spacing. This way, when the data is displayed, it looks neat and structured like a table. Now we use a while loop with rs.next, which goes through each record returned by the query. Inside the loop, we fetch the values of each column, course ID, course name, instructor, duration, and fee. Then, using system.out.printf, we print each record in the same table format as our header. Finally, we set found equals true to indicate that at least one record was retrieved from the table. After the loop ends, we check if found is still false. If it is, that means no records were retrieved from the database. In that case, we simply print a message, "No courses found in the table." This ensures the user gets proper feedback even when the table is empty. Finally, we close this case with a catch block to handle SQL errors. If anything goes wrong while fetching the data, it will print error while fetching courses and show the error details using e.print stacktrace. Then we use break to end case 1. Looks like our instructor field name is not matching with the actual database column. So before running the program, let's quickly check the table structure in MySQL using To verify the exact column names in our table, we use the SQL command. Describe courses. This will display all the columns along with their data types. If we find that the column name for instructor is different, we'll update the same in our Java code. Now that we've verified the column names and corrected the field name in our Java code, let's run the program again. This time, the system should fetch all the courses properly and display them in a neat tabular format. If the table contains records, they'll be shown with columns like course ID, course name, instructor, duration, and fee. Perfect. We got all the records successfully. The table is now displaying every course with its ID, course name, instructor, duration, and fee without any errors. This confirms that our JDBC connection, SQL query, and result display logic are all working properly. Now let's move to insert operation, where we can add a new course to our database. First, we print the heading, Insert New Course. Next, we define our SQL query using a prepared statement with placeholders for course name, instructor, duration, and fee. We then ask the user to input the course name, instructor name, duration, and course fee using the scanner object. After getting the inputs, we set the values in the prepared statement using setString, setInt, and setDouble. Finally, we execute the query with execute update and print a confirmation message showing how many courses were inserted. Once we set all the values in the prepared statement, we execute it using execute update. This returns the number of rows affected, which we store in the variable row inserted. We then print a confirmation message showing how many courses were successfully inserted. If any SQL error occurs during this process, the catch block will handle it by printing error while inserting course, along with the detailed exception using e.print_stacktrace. Finally, we use break to exit this case and return to the main menu. Now, let's run the project and test if everything is working properly. We'll select Insert Operation from the menu and enter the details for a new course, including course name, instructor, duration, and fee. Once we submit the inputs, the program executes the SQL insert query and displays a confirmation message showing that the course has been successfully added to the database. This confirms that our insert operation is working perfectly. Next, let's perform the update operation. Inside case 3, we start with a try block to handle any SQL exceptions safely. If any SQL error occurs, the catch block will handle it, printing a friendly error message and the exception details. Now, the program asks for the new duration in hours. We store that value in up duration. Finally, we ask for the new course fee and store it in up fee. After collecting all the inputs, we set them one by one in the prepared statement using setString, setInt, and setDouble. The last parameter is the course ID, which ensures that only the selected record gets updated. We then execute the update query using executeUpdate. The return value tells us how many rows were updated, and we display that as a success message. Now, let's run the program and check the update operation in action. The program ran successfully, and our update operation worked as expected. Now, let's perform the delete operation. When we select option number 4 from the menu, the program asks us to enter the course ID of the record we want to remove. That ID is then passed into the prepared statement, and the SQL delete query is executed. If the record exists in the table, it will be removed permanently, and the program will display a confirmation message showing how many course records were deleted. In case of any issue, the catch block will show an error while deleting the course, along with the exception details. We define our SQL delete query, which will remove a course based on its course ID. Here, we prepare the SQL statement using a prepared statement object. Then, we prompt the user to enter the course ID that they want to delete. We read the course ID input from the user. This line is used to consume the new line character left in the input buffer. Now, we set the course ID value inside our prepared statement at the first placeholder. Then, we execute the query. It returns how many records were successfully deleted. Now, let's run the program and test the delete operation. Finally, we get a confirmation message showing how many course records were successfully deleted. Now that we've implemented all 4 operations, let's test them one by one. First, we'll use the select operation to view all the existing courses from the database. Next, we'll perform the insert operation by adding a brand new course record. Then, we'll test the update operation by modifying the details of an existing course. After that, we'll check the delete operation by removing a course record using its course ID. This way, we can validate that our Java JDBC CRUD project is working perfectly end-to-end. I hope this video helped you understand how JDBC works step by step. If you found this tutorial useful, don't forget to like the video, subscribe to the channel, and press the bell icon